All right, so this is the beginning of Chapter 2, and in Chapter 2, Section 1, we're going to be talking about complex numbers. Most of what we're going to do in this section you did in Algebra 2, so hopefully it'll be a good foundation, a good review for you. Complex numbers are of the form a plus bi, where a is our real part, and then b is our imaginary part. And when we're adding and subtracting complex numbers, it works very similarly to combining like terms. We'll keep the real parts together and the imaginary parts together. A term that we're going to see over and over again, and you've actually seen this term in reference to radicals, we can talk about the complex conjugate. And these two terms right here would be complex conjugates. The real part is the same, the imaginary part is the same, but the sign in between is different. It's the opposite. We can also talk about the principal square root of a negative number. If I have negative b, the square root of negative b, then I can pull the I out and talk about the square root that way. Now, one thing we want to make sure when we're simplifying radicals is to make sure that we rewrite something written like this, before we start combining like terms or multiplying or anything like that. So let's go ahead and dive in and get to some examples here. This first example is asking us to subtract, and we want to make sure we distribute that subtraction here. So we have 6 minus 8i minus 3i plus 1, and we've got our real part here, and that'll be 7, and then we've got the imaginary part here, and that's minus 11i, and that's our answer. And looking at the next one, we're multiplying, and we want to distribute. And one thing we're going to need here, actually, that I didn't mention above, is that I squared is equal to negative 1. Okay. So 7i times 2 is 14i, and 7i times 9i is going to be 63i squared. But again, we're replacing I squared with negative 1. So now we have 14i, and we have a negative 1 here. So 14i minus 63 times negative 1. Well, a negative times a negative is going to be a positive. So we have 63 plus 14i. And the standard form of complex numbers is to write the real part and then the imaginary part second. Looking at the next example, we're going to need to either FOIL or use the box method or whatever method you like for multiplying. I'm going to use a box just to demonstrate how a box can help keep things organized for us. If I have 6 minus 7i, and then I have 5 plus 4i, 5 times 6 is 30, 6 times 4 is 24i, 5 times 7, negative 35i, and negative 7 and positive 4 is negative 28i squared. And now we're just combining like terms. So I have 24 and negative 35, and that'll give me negative 11i. And this I squared here we know is really a negative 1. Well, a negative 1 times a negative 28 is a positive 28, and then 28 plus 30 is going to be 58. Now, when we are dividing complex numbers here, we're going to multiply the top and the bottom by the conjugate. Very similar to how we rationalize a radical expression. Okay, so I'm going to multiply by 2 plus 5i over 2 plus 5i. And I'm going to use this box, but I'm not going to show my work for this. I'm just going to do this in my head here. So 7 and 2 is 14. And then, let's see, 7 and 2 is 14, 7 and 5i is going to be 35i, and then we've got 4i and 2 is going to be 8i, and then 4i and 5i is going to be 20i squared. And on the bottom, I'm going to have 2 times 2 is 4, and then we've got 2 times 5 is 10i, negative 5i is negative 10i, and we'll end up with minus 25i squared. Okay, so that's where we're at right now. Now, couple things. When we multiply by the conjugate, there's something special that's always going to happen. these I terms are always going to cancel out. We have a positive 10i and a negative 10i. So right away, I know that I'm just going to end up having 4 minus 25i squared. Now this I squared is really negative 1. So I have 4, and then I have minus a negative, so that becomes positive. So 4 plus 25 is going to end up being 29. Now on the top, I have this I squared that's also negative 1. So I really have a negative 20 right here, and a positive 14 is going to give me negative 6. And then I have 35i and I have 8i. So that would give me 43i. And you can write your answer like this, or if you want, you can write it as negative 6 over 29 plus 43i over 29. Either one of these is fine. Okay. And that's number 4. And now let's look at some problems like this, where we have not rewritten things in terms of I here. We want to make sure that we're careful with that, because if we do things in the wrong order here, we're going to end up with the wrong answer. I need to simplify these and rewrite them in terms of I before I do anything else. Well, I have I and then square root 27, and then I have I and square root 48. And 27 is 9 times 3, and 48 is 16. Let's see, 16 times 3. And so I can take those square roots, and square root of 9 is 3, so I have 3i root 3, and plus 4i root 3, and so that's 7i root 3. Okay, looking at the next one, like I said, this is where we're going to see how important it is that we rewrite this first. So I have negative 2 plus, and this is going to be I square root 9, which is 3i. So 3i squared. And again, you can use the box to multiply or whatever method you prefer. I'm just going to, again, do the box method, but I'm going to do it in my head. I'm not going to show my work for this. I'm going to end up with 4 minus 6i minus 6i and plus 9i squared. And that I squared, again, is just equal to negative 1. So I have negative 1 times 9 is negative 9 plus 4 is going to give me negative 5 and minus 12i. Okay. And then this bottom one here, again, I want to simplify my radical here. Now if I have the square root of negative 12, that's like the square root of I times square root 12. And 12 is 4 times 3. So I can rewrite that as 2i root 3. So I have negative 14 plus 2i root 3 over 2. And I can simplify both of those. This can turn into a 7, and those reduce. So we're left with negative 7 plus I root 3. All right, and I'm going to go ahead and flip the page. And now we can actually talk about the quadratic formula with a little bit more detail here. So we have the part of the quadratic formula here. Go ahead and fix your notes. Obviously, we're missing part of the quadratic formula. We're missing that negative b plus or minus. So what your quadratic formula should be is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to just solve some examples using the quadratic formula here. Now, my a value is 3, my b value is negative 2, my c value is 4. X is equal to negative b, so in this case 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c over 2a. Now it's just a matter of simplifying things here. So I have 2 plus or minus the square root, and 4 times 4 is 16, times 3 is 48. 4 minus 48 is negative 44 over 6. And we can rewrite that square root here. I know I need to pull the I out, and I know that 44 is 4 times 11, so I can pull a 2 out, and I'm left with 11 underneath. And I have now 2 plus or minus 2I root 11 over 6, and I can reduce that a little bit. I have 1 plus or minus I root 11 over 3. And again, if you want, you could separate these into different fractions. You could write this, if you'd like, as 1 over 3 plus or minus I root 11 over 3. Either one of these is fine. Okay. Our last example of this section, we're just squaring this right here. And again, we want to make sure that we simplify this first here. So I have negative 2 plus I root 11 squared. And I'll just do one more example of actually working out the box here. I have negative 2 I root 11 and then negative 2 and I root 11. And that's going to be 4. This is going to be 11I squared. This is negative 2I root 11, negative 2I root 11. And now we have this, which is negative 1. So negative 11 and 4 is negative 7 minus 4I root 11. And that is the end of section 2-1.